So hello everyone, my name is Christian Bataller from Bsit 11. And this is my presentation of the summary of chapter 1 and chapter 2. So the chapter 1 topics cover are intro to computers, elements of a computer systems, classification of computers, capabilities and limitations of computers, and last is history of computing. So my main objectives for today is to discuss the brief summarization of chapter 1 and chapter 2. So let's proceed now in our topic. So what is computer? Before I start, I would like to give an emphasis to everyone that computer is one of the necessary thing that we need today, especially in students and workers. Since magagamit nila or natin yung computer sa pagtatrabaho at pag-aaral dahil mas napapabilis nito ang ating mga gawain. So, computer is an electronic device that manipulates information or data. Also, it is a device that could program to automatically perform series or logical or mathematical processes. Typically, combination of action referred as programs can be executed by contemporary digital electronic computers. So this application give computers the ability to carry out a variety of tasks. So marami ang nagagawa ng computer. In that, there are three main components of computer, which is the hardware, software, and people. Hardware equipment associated with a computer system, while software is a set of instructions that tells the hardware what to do. Like what you see on my presentation. So the hardware are system unit, monitor, keyboard, printers, headset, speaker, mouse, etc. And the software are Chrome, Gmail, Word, PowerPoint, Java, and other program, and the Android system. So people or us are the one who use the power of computer for some purposes. Like for example, me, I'm presenting my presentation in this subject. So there are four main types of aspect of data handling, which is the input, processing, storage, and output. Input are taking information that is external to the system and entering it into the system. Processing, an action performed of the data. It can include sorting, searching, or performing calculation of the data. The storage, where data is held and still in the system. It may be the data that has been input, required during processing, or result of processing. While the output is taking information that was in the system and outputting it may result in a printed on screen or electronic. So let's go now in elements of a computer system. So program. Program is a computer program. It's a sequence or a set of instruction in a programming language for a computer to execute. It is one component of software which also include documentation and other intangible components. A computer program in its human readable form is called source code. Next, the hardware. The hardware that physical device that constitute a computer system. Hardware refers to all tangible parts of a computer or yung mga nahahawakan natin. Like, nahahawakan or yung sa external part of the computer, like central processing unit or the CPU, random access memory or RAM, read-only memory or ROM, and external memory, and so on and so forth. So let's now go in input and output devices, or 1 or 0 device. So when we say input, a piece of equipment or hardware which help us enter the data into computer, while the output device is piece of equipment or hardware which give out the result of the entered input. So here's the example of input device. Light pen, touchpad, voice input, and etc. And the output is printer, monitor, and speaker. So software. Let's go here to software. Wait for a minute po. An application or the system software. The system software is designed to run a computer's hardware and provides a platform for application to run on top of. Like for example, the Linux, Windows, Android, and the Apple or the Macintosh. While the application software that fulfills a specific need or perform tasks, kung ano yung mga nagagamit nating application, mapa-website man or sa phone, like Chrome, Adobe Photoshop, and many more. So let's go now in classifications of computer. Data handling, the act of obtaining, documenting, and presenting data, which is present raw form in a way that enables analysis, prediction, and decision making. So functionality, we have supercomputers in which the mightiest computers and of course the most expensive are known as here, supercomputers. It is process billions of instructions per second. Most people, lahat ng people ay nagdadirect ng need for the speed and power of a computer. Sa mainframes, in the jargon of computer trade, large computers are called mainframes. Very high speed millions instructions per second and have access to billions of characters of data. Notebook computers, also known as laptops, kung ano yung mga nadadala natin, because it is portable and functional. And popular, ayun nga sa mga travelers, na kung saan nabibitbit. And personal computers, na tinatawag din nating PC. They range in a price from new $100 to a few $1,000s while providing more computing power than mainframes of 1970s that filled the entire rooms. Next, the capabilities and limitation of computers. So capabilities of a computer, kung tayo merong capabilities and meron din yung computer. So I have 3 capabilities of a computer here. It is automatic. The computer can do things at the same time. Computer can also multitask like us. and the computer can be improved and upgraded, and many more. I just write three here. So capabilities of a computer also comes with its limitation. Kung tayo may capabilities and pati yung computer and meron din tayong limitations. And also the computer has its limitation. So I have three here again. Limitation of a computer can only do what you tell it to do. It has no thinking capability like human, since we have brain. Computer has no thinking capabilities. So kung meron tayong thinking capability, yung computer wala, kasi tayo yung gumagawa or nagpo-provide ng kung anong gagawin ng computer. That's why walang thinking capability ang computer. So it cannot generate information on its own. So kailangan yung people ang bibigay ng gagawin ng computer. I mean, tayo yung mag-a-access or gagawa ng way para makapaggawa ng task natin sa isang computer. So history of computing. Pre-modern, before we tackle that, computing refers to the process of using electronic or mechanical devices that devices to manipulate and process data, perform calculations, and execute instructions. So yan, sinasabi ko. Pre-modern computing, mechanical computing, age of electromechanical computers, the birth of electronic computers, the transistor revolution, the rise of personal computers, the internet, and modern computing. In pre-modern, the earliest computing device focused on calculations easier and quicker, which is the abacus. It is counting board with beds or disks that can be moved, track numbers in an early predecessor to the modern computer. The abacus has been used for calculations since 1100 before Christ. Mechanical computing have been used to process information for millennia, with famous examples ranging from the Antikythera mechanism of the ancient Greeks to the analytical machines of Charles Babbage. Age of electromechanical computers, Per and Edwards Schutz, 1853, complete their tabulating machines capable of processing 15-digit numbers, printing out results, and rounding off to 8 digits. The birth of electronics computers, the Electronic Numerical Integrator in Computer, or ENIAC, developed in 1945, was the world's first general purposes electronic digital computer. It is used to vacuum tubes for processing and played a critical role in scientific calculations and early computing research. The transistor revolution, it was in December 1947 that these scientists first demonstrated the functionality of the point contact transistor, paving the way for the electronic revolution. With the transistor, the era of vacuum tubes gradually came to an end, ushering in a new era of miniaturization and efficiency in electronic circuits. The rise of computers. The personal computer's history as a consumer electronic device for the masses actually began with the introduction of the microcomputer in 1977. Although some mainframes and mini-computers were applied as a single-user systems long before that. And the internet is a vast network that connects computers all over the world. Through the internet, people can share information and communicate from anywhere with an internet connection, like what we are doing. Without internet, we can't use any social media platform in computers. And last is modern computing. The development of microprocessor in the 1970s revolutionized personal computing by miniaturizing computing power, making it affordable, and putting it in the hands of individuals. Also, quantum computing based on the principle of quantum mechanics promises to solve complex problems exponentially faster than classical computers. And the advent of cloud computing in the 2000s transformed data storage uh, and access. Services like Amazon Web Service, Microsoft Azure, and Google Cloud offer scalable and cost-effective computing resource over the internet. So let's proceed to chapter 2, in which conversion. And the covers topic of it is binary number system, how to convert binary to decimal, and converting decimal to binary, octal number system, hexadecimal number system, um, how to convert octal to hexadecimal and hexadecimal to octal. So binary number system and decimal number system. Binary system is one of the four types of number system in computer application, where binary numbers are represented by only two symbols or digits, which is the 0 and 1. The binary numbers here are expressed in the base 2 numeral system. For example, 1, 101. Wait lang, I will use annotation here. So for example, I will put open parenthesis 1, 0, 1, close parenthesis, and I will put here 2 to make it to make it binary. So let's go now in conversion. Converting binary to decimal. So I have here sample number 1 and 2. In sample number 1, I just put 11001. And to make it decimal, we will just start in right number. So here we're going to start here. I will just put 1 and we will double it. 1, 2, double natin yung 2 is 4. Double ng 4 is 8. And yung double ng 8 is 16. So after that, we will disregard this number, yung 0. So I will encircle 16, 8, and 1. After encircling, we will just add them to get the decimal number system. So 16 plus 8 is 24. And 24 plus 1 is 25. So the decimal number of this sample is 25. So let's proceed to 2. So I have here 10101. Then to get the decimal, again, we will just start in right number. 1. I will put 1 and I will double it. 2, double it. 4, double ng 2 is 4. Double ng 4 is 8. Double ng 8 is 16. So I will disregard the 0. So I will encircle it 16, 4, and 1. So 16 plus 4 is 20. 20 plus 1 is equal to 21. So the decimal number of this sample is 21. So now, let's proceed sa conversion ng decimal to binary. So in decimal to binary, we will just reciprocate sa kung anong ginawa natin sa previous, yung binary decimal. So, I have here sample number 1 is 31, sample number 2 is 32. We will just put 16, yung double number kanina, yung mga dinoble nating number kanina, 16, 8, 4, and 2, 1. 1, 2, 4, 8, 16. So, para alam natin na hindi siya mag-exceed, since 31 lang naman, ito lang yung number na ilalagay natin. So, dito naman tayo mag-i-start. I-add natin, mag-isip, titingnan natin kung ano yung pwede natin ipag-add to make it 31. So, 16, I will just put here 1. 16 plus 8 is 24, so I will put here 1. 24 plus 4 is 28, I will put here 1. 24 plus 2 is 30, so I will put here 1. And 30 plus 1 is 31. So, lahat siya is 1 kasi yun yung way natin para ma-add, para makuha natin itong 31 na decimal. So, ito yung binary niya. 1, 1, 1, 1, 1, 1. Limang 1. So, next is yung 27. Para makuha natin yung 27, again, uulitin natin yan, 16, 8. Since hindi naman nag-exceed yung 27 sa ibang number, so hanggang 16 lang tayo. 16, 8, 4, 2, and 1. Kapag nasa bigger number na siya, like mga 56, ganun, 40 plus, 30, 40 plus, we will just put 16, 32, and so on and so forth, like that. So, since 27 lang yung sample number 2, hanggang 16 lang. So, mag-start tayo dito 16 para makuha yung 27. So, 16, I will just put here 1. 16 plus 8, 24. 1. So, 16 plus 4 is 20. 16 plus 8 is 24. Plus 4 is 28. So, hindi na siya exact. So, I will put here 0. Kasi pag nilagay kong 1 dyan, magiging 28. So, hindi niya makukuha yung 27. So, 24 plus 2 is 26. I will put here 1 since kulang pa. Then, 26 plus 1 is 27. I'll put here 1 again. Yan. So, that's why naging 27. So, 16, 8, 2, and 1 to get the output, which is 27. So, now, let's proceed sa octal number system and hexadecimal number system and its conversion. So, octal number system is system a base 8 number system and uses the digits 0 to 7 to represent numbers. While the hexadecimal number system is a base 16 number system and uses the digits 0 to 9 along with the letters A to F to represent numbers. So, yung A to F ay may kaakibat na numbers. So, makikita natin siya mamaya. So, proceed tayo sa conversion to octal to hexadecimal. To convert octal to hexadecimal, so we will just put 6, 4, 2 here. We will just set aside them. So, yung sample is 642 octal to hexadecimal. Ito yung kaakibat na letters to numbers. So, yung 10 is equal to 8, 11 is equal to B, 12 is equal to C, 13 is D, 14 is E, and last, 15 is equal to F. To get the octal to hexadecimal, we will just convert it number, this 642 to to binary. So we will just convert it to binary. So 1, 2, 4. Kaya siya ganyan kasi in octal, we have 3 bit. That's why it is 4, 2, and 1. Again, we will just write it 1, 2, and 4. 1, 2, and 4. To get the binary, we will need to know kung ano yung pwedeng ma-add sa number. So, yung 6, to get the 6, we will just 4 and 1. Then we will, since hindi na pwede yung 1, kasi magiging 7 na, so 0. Again, sa pangalawa, 4, so lalagyan natin siya ng binary 1, 0, 0. 4 lang kasi di na natin nilagay yung dalawa kasi nga mag-exceed na siya sa number 4. So here, last is 2. So 1, no, sorry, 0. Since exceed yung 4 sa 2 masyado. So ito 1. Since 2 is 2 and 0. Kasi pag pinag-plus yung 2 sa 1 is magiging 3. So hindi niya makukuha yung binary. So yung binary niya is 1, 1, 0, 1, 0, 0, 0, 1, 0. And after that, we will just regroup it into hexadecimal. So 1, 1, 0, 1, 4. 1, 0, 1, 0, and 0, 0, 1, 0. 0, 0, 1, 0. Then after regrouping, so since apat sa 4-bit sa hexadecimal, i-regroup natin siya ng 4. That's why ganyan. 4. Itong dapat may 0 dyan, so pwede naman natin siyang i-disregard. So kahit hindi na ilagay. Hindi ko na nilagay. Then, after that, we will just put here sa right number. Again, 1, 2, 4, 8. Since 4-bit lang. 1, 2, 4, 8. And 1. And after that, we will just simply multiply these numbers. So 1 times 1 is equal to 1. 1 times 8 is equal to 8. 0 times 4 is cannot be. So, di-disregard natin yan. 1 times 2 is 2. So, we will just put it here. 2, then add 8 plus 2. And 0 multiplied by 1 is cannot be. So, we will just proceed sa next group. So, 0, 0, 0, 0, 0, 1 times 2 is equal to 2. Then, disregard this one because it is cannot be. 0 times 1 is cannot be. So, 8 plus 2 is equal to 10. Then, 10 is represent the letter A. So, I will just put here 1, A, and 2. So, the octal to hexadecimal of 642 is octal 1, A, 2 to hexadecimal. So, now, we will, next, we will proceed in hexa to octal. So I have given example here. C8 hexa is equal to octa. We will just convert it to octal. So here again, the letters A to F to represent numbers. So 10 is equal to A, 11 is equal to B, 12 is C, 13 D, 14 E, and last 15 is F. So to start, I will just annotate. So I will write C here, and we will just find the value of C, which is 12. So here I will put 12 here, and 8, I'll write 8 here. Then since hindi naman siya letters, so I'll write 8 na lang here. Then after that, I will we will find the binary of this. So 1, 2, 4, and 8. Dodoblehin natin siya. And again, sa kabila din, 1, 1 double of 1 is 2. Double of 2 is 4. Double of 4 is 8. To get the binary, we need to add to get the exact number here, the 12 and 8. So 8 plus 4 is 12. So I will just put here 1, 1, and the rest is 0. And here in 8, I will just put here 8 since yan naman na yung last number. Since hindi naman na pwede add tong 4, yung kasunod niya, kasi mag-exceed na siya sa number 8. So I will put here sa 8 is 1. Then the rest is 0. Then after getting the binary, we will just regroup it in octal. So we have 3 bit. Sa 3 bit natin siya i-regroup. Kasi yung nauna is 4 since hexa. 3 siya. So here, I will just put the 0 here, but we will disregard that. We can put it naman, but wala namang problem lang. So we will just try to put it. So regroup it into 3. Since hexadecimal to octal, and octal has 3 bit. So 0, 1, 1, 0, 0, 1. It's 0. Ang hirap mag-annotate. 0, 0, 0. Sorry for the font of my writings because the annotation here is kinda hard. Then after that, we will just start again in right numbers. So 1, 2, and 4. 1, 2, and 4. 1, 2, and 4. 4, 2, 1. And right after, we will just multiply. 0 multiplied by 4 is cannot be, so disregard. 1 times 2 is 2. 1 times 1 is 1. So plus, we will add here and 1. 0 times 4 is cannot be. 0 is 2 is cannot be. 1 times 1 is 1. 0 is 2 is cannot be, and 1 times 1 is 1. That's why I put here 1. 0, so this all number of this group is 0, so that is cannot be. So 2 plus 1 is equal to 3. Then number itself, number 1, sa next group. In next group rather. So here, I'll put here 0 na lang kasi 0 naman yung value. Then after that, we will just write here the answer. So C8 hexa is equal to 3. Oops, again. 3, 1, and 0 to octal. So that's the final answer. So that's all for today. I hope I discussed the summarization of chapter 1 and chapter 2. Thank you, Ma'am Almi, and thank you, classmates.